Hello and welcome to the latest in our series iFormulate Revisited. My name is Jim Bullock and around 7.5 years ago I co-founded iFormulate Limited with my colleague David Calvert. We thought that some of you would appreciate viewing some of our many conference presentations on various formulation topics, so we've recorded and updated a number of these. And this time we are revisiting a talk I gave at the CIR Agrochemical conference in Nice in 2017 on what's new in formulation, with a focus on conventional agrochemicals as well as biopesticides. Along the way I'll be reflecting from now, April 2020, to see if the comments we made in 2017 are still valid. Before we start, here is a quick overview of iFormulate and what we do. Our main activities are in consulting on formulation science and technology to companies in a range of industries. We find that good ideas from one industry can often be applied in another. We have also carried out strategic projects on formulation for industry and innovation bodies, such as the Royal Society of Chemistry, Innovate UK and the UK's National Formulation Centre. We also produce and deliver training courses under our own banner as well as in collaboration with partner organisations. Further details can be found on our website or via the email addresses on this slide. Today we are talking about agrochemicals, so here is a summary of our activities and experience in this area. Most of our work has been for individual clients, so individual client projects have included supporting formulation development and troubleshooting projects, scouting for novel formulation technologies, assistance in positioning new technologies on the market, for instance. We've also carried out training activities together with our partner ATI Informa, so that's included in-person and online training on an introduction to agrochemical formulation strategies, as well as a new online training course on applying design principles to agrochemical formulations. We've also written on commission from Agribusiness Intelligence a number of reports. These include Agro Formulations in 2016, Agro Sustainability in Biochemicals 2018, Bioformulations 2020 and Agro Formulations 2020, which is in preparation at the moment, due to be released later this year. So here is an overview of today's presentation. We will revisit the comparison made of formulation trends in 2017 when we compared to what was happening in 2013. Then we'll look at whether old formulation types are really dying out. We'll then ask ourselves the question, is nanotechnology really a big thing for agrochemicals? And then we'll ask a related question, is microencapsulation a big thing for agrochemicals? We'll concentrate for a short while on complex mixture formulations and resistance, as well as how biopesticides are being formulated, before finishing with a summary. So let's look at those trends in more detail. First, biopesticides. The 2013 Agro Formulations report had noted the growth in biopesticides and the technical challenges in formulating them. That trend had continued to 2017 and continues now. Next, regulatory requirements for co-formulants. Well, these always seem to go in just one direction, so that trend continues, and relatively recently, in fact, the EU authorities have begun drafting a negative list of co-formulants. So there's a tick in that box as well. In 2013, it seemed that some of the older formulation types might be on their way out. We're now not so sure that that's still the case. We'll come to that topic in a moment, and so therefore we've put a question mark in that box. The next trend was about adjuvant use to improve efficacy. Subjectively, this shows no sign of abating, with pressure to reduce spray drift and volatility, as well as using AI generally more effectively and efficiently. From a 2020 viewpoint, there seems to be still a lot of innovation activity. And the next one, generic suppliers are, if anything, gaining a higher market share than they were in 2013 or even 2017. AI registration and development remains costly. And with the recent reviews in restrictions on glyphosate and neonicotinoids, this has made it a risky business to be in. The next trend was about outsourcing of development work. Well, that continues, and that continues at a high level in order to make best use of expertise, resources and time. It's a bit difficult to say that that's a growing trend. However, it's there, and it's always been there, and it's still there. Patent activity, yes, that does seem to be growing too, although we shall see later that doesn't always say that those innovations will turn into commercial innovations. And what about the new trends we identified in 2017? Well, there was pesticide resistance and the implications of that on formulation. More on that in a moment. The combination of treatment regimes, so using a resistant strain, a strain resistance to a herbicide together with that herbicide. We thought that there was an increase in activity in integrated pest management. So that's looking at the whole ecosystem and taking a holistic approach to pest control that often involved combining natural solutions together with synthetic ones. We could see the beginnings of a wave in restrictions and prohibitions on major active ingredients, such as neonicotinoids and glyphosate. And we saw the beginnings of a potentially groundbreaking trend on smart agriculture. So that's the automated application process, robotics, data analysis, all put together, combined together to give a potentially much more cost-effective and environmentally acceptable solution. So the first question then, are old formulation types really dying out? Let's have a look at those older formulation types. With this slide, which we put together in 2016, we took data from the online pesticides manual. The numbers and areas on the pie chart relate to the number of formulations on the market which are manufactured in that particular formulation type. The older types are the ones in grey, together about 2/3 by number, dominated by EC, emulsifiable concentrate, which contains solvents which are often undesirable, and WP, wettable powders, which can generate dust. The newer type, which are the green ones over on the top left-hand side, make up about 1/3 of the numbers of formulations, with SC, so water-based suspension concentrates, and WG, free-flowing, low-dust water dispersible granules, the formulation types which dominate. In 2016, we compared the numbers for formulation types with the same numbers reported in 2013, and a little surprisingly at first, the older types hadn't started to die out. There could be many reasons for this, but in the case of EC formulations, solvents which are potentially toxic and flammable have been replaced by newer, greener solvents and even oils of natural origin. So we thought about putting together some more up-to-date data for this update in 2020. What about looking at market sales value rather than numbers of products? And for the upcoming 2020 Agro Formulations report, we've looked at some data from the AgriSpire database, which breaks down sale by formulation types. Here's just one chart from our analysis. EC is still there again at about 1/4 of the value, so it's certainly not dying out. And it looks set to be there for some time as an important formulation type. Moving on to technological developments, back in 2013 there was certainly a lot of talk of nanotechnology becoming increasingly important in formulation. So what happened since then? Here is a definition of nanotechnology. It's concerned with materials which have one dimension in the nanometer range. We've listed here some of the benefits claimed in different industries. In the industries we're interested in, it's particularly about solving problems and efficacy as well as delivery of the active ingredient. And that's where it seems to have been used, or at least innovations appear to have started in those areas. On the downside, there were and continue to be concerns that producing substance or structure on the nanoscale could potentially render it more hazardous to humans and the environment. So regulations have certainly had the technology under intense scrutiny. In 2016, we carried out a patent survey. This slide looks at nanotech patents both in agrochemicals as well as in other industries. The orange bars on the chart show numbers of nanotech patents in all industries. These peaked in about 2010 and have remained at roughly the same level ever since. The blue bars represent the same figures, but just for the agrochemical industry. These have grown steadily over the years, and then the black line is the percentage of agrochemicals as patents in nanotechnology of the total. This shows them being relatively important on the left-hand side in the early part of the century before declining and then picking up a bit around about 2012. And the final bars on that chart should be ignored for the purpose of this analysis. They don't represent a full year. Next, we looked at agrochemical patents for nanotechnology in more detail. The blue bars are the absolute numbers of agrochemical nanotech patents filed with the Chinese Patent Office. And the orange line represents this number as a percentage of all agrochemical patents. Whichever way you look at it, China has certainly been on the rise in this area. Next, and still with our 2016 spectacles on, we looked at what the big six, as they were then, agrochemical producers were doing in nanotechnology. Of course, due to mergers since 2016, the big six are now the big four. The blue bars on this chart show the absolute numbers, a little bit more noisy, but the trend is upwards in general. Relative to all agrochemical nanotechnology patents, however, the orange line shows a decline. So the big six were patenting and continue to patent over that time space, but not as fast as China was doing. So we looked at commercial activity, and in the Agro 2016 report we go into more detail. Although we found some examples of nanotechnology being commercialized, they were relatively few and far between. In fact, our findings mirrored those of an EU report from 2014. I won't read the whole slide to you, you've got it in front of you, but the first two sentences sum it up pretty well. There are over 3,000 patents, that's 2014, worldwide for potential agrochemical use of nanotechnology. However, in reality today, very few, if any, intentionally manufactured nano-sized formulations exist on the market. And whether it's due to safety and regulatory concerns or just to a poor commercial cost-benefit analysis of the technology isn't clear, but either way, I think from a 2020 viewpoint, those sentences still more or less hold. The next technology we looked at was microencapsulation. It certainly also gets talked about a lot. It's scientifically quite interesting, and certainly technical benefits can be realized for formulations. But is it actually a big thing for agrochemicals? And again, here are the figures, this time for microencapsulation patent filings on agrochemicals up to 2015-2016. Pretty significant increase is what we can see from 2010 to 2014 or so, maybe falling a little bit after that. So where did that spike come from? And there's a lot of information on this chart of agrochemical patents where microencapsulation got a mention. Let's go through each set of bars in turn. The blue bars are World Patent, WO patent applications. The grey bars are US patent applications, and the yellow bars are European patent applications. Again, in those three sets of bars, there are some ups and downs, but essentially we're going up to, on an upwards curve, to about 2010, 2011, and after that plateaus off a bit. The orange bars are those Chinese applications once again. So that's that big spike from 2011 onwards that explains the rise in the previous chart. And what of the big six? Now the big four, of course, again here. There are some differences between the companies. Bayer seemed to peak in the microencapsulation area in the early part of the century and then dropped off. There are peaks for Syngenta, BASF and Dow in patent activity a little bit later. We suspect that that relates to the properties of those actives coming through the company pipelines at the time. Some of them required microencapsulation and some didn't. Microencapsulation is a problem-solving formulation. It won't always bring benefits, and it's too complicated and expensive to be used for every new active ingredient. So it's used selectively according to the need. But that's not to say that there aren't commercial products and innovations out there. On an earlier slide, we have seen that there are a number of commercial products on the market, and here on this slide are some examples of innovations in microencapsulation. I won't read them through, but do get in touch with us if you want to discuss the subject some more. One formulation theme that has grown in importance over time has been the need to formulate complex mixtures of active ingredients to combat the growing problems of pest resistance. And here is an example. This is Syngenta's herbicide mixture, Acuron. This slide is taken from publicly available information. The product contains 4 herbicide active ingredients plus a herbicide safener, which is effectively a 5th active ingredient. You can see that one at the bottom, Benoxacor. You can see here that they have a wide range of physical properties. So, for instance, solubility and melting point vary significantly across those actives. Each active ingredient will have an optimum formulation type, but they all have to end up in one formulation. The actives with a higher melting point and low water solubilities can be formulated as suspensions, and the lower melting point insoluble active metolachlor is presumably a liquid active ingredient encapsulated in a polymer shell, making it effectively a suspension as well. Indeed, the product is actually described as a ZC product, which is a mixture of a capsule suspension CS and a suspension concentrate SC. So that explains some of the active ingredients, but that's not the end of it. The first 2 actives on the list have a high water solubility. They can't be suspensions as they will dissolve in the aqueous phase. So presumably the formulation is an SL, a soluble concentrate, for those 2 actives. And those are some assumptions made. We don't have any details, any secret details of the formulation of that, and that's some deductions made from the physical properties. But overall, it's a complex formulation, and formulating those 5 actives together would be a big technical challenge. We mentioned biopesticides briefly before, so let's have a look at how they are being formulated. First of all, biopesticides cover a very broad range of active materials. Each category of actives could present the formulator with a different challenge. So you might have natural extracts, so chemical entities or mixtures of things like water-soluble or oil-soluble essential oils. Biochemical entities with a specific biochemical functions like peptides, enzymes or proteins. Or organisms which are bacterial or fungal in nature. And here are some examples of those sorts of actives. So there are microbial actives, so things like Bacillus thuringiensis, Beauveria bassania and so on. Biochemical extracts such as pyrethrum and neem are very popular. Macrobial organisms can be formulated and sold, so even predators and parasitoids can be formulated, and other organisms such as nematodes or attractants and repellents, things like pheromones, may be formulated. So that term biopesticides is covering a huge range of very different actives. So why might biopesticides be difficult to formulate? Well, the main reason is stability. That's always an issue in agrochemicals, of course, but here we're dealing with the actives that nature has given us rather than synthetic ones that have been designed for a particular purpose. And we are asking a biopesticide to do a job other than that which they have evolved to carry out, or under different conditions other than those which evolution has produced them under. So they tend, for those reasons, to be suboptimal for stability. And here are the common challenges: physical, chemical, UV and heat stability. And on top of that, living organisms have to be kept alive, but not proliferating, for a long time during manufacture and storage before use. A further issue is variability. Active materials can vary considerably according to their source or the season during which they were obtained. And they're most often complex mixtures, and we may not know which of the components is most significant to the efficacy in application. Let's look at how, first of all, natural extracts are being formulated. This is by numbers of products, not by market value. The data here are slightly old now, but we will show some more recent data in a moment. Extracts will be water-soluble or water-insoluble, of course. Now, water-soluble actives can be formulated as solids, as SP, soluble powders, or liquids, soluble liquid concentrates. Water-insoluble actives can be formulated as WP, wettable powders, or EC, emulsion concentrates, if a liquid is preferred. And you can see that these simple and cheap formulations represent a big majority of the formulation types on the market. So together those three that I've mentioned forming nearly 70% of all the formulations by number that are on the market. Moving on to living organisms, how are they formulated? Well, they aren't soluble, of course, but they can be dispersed in water or oil. In water, however, on storage, they can proliferate, consume nutrients, and then die off even before they're used. So wet formulations tend not to be preferred. And as we can see, dry formulations, powders and granules form the majority of formulation types on the market by number. Here are some more recent data on microorganisms taken from our 2020 Bioformulations report. Just looking at new products this time, so products launched in the previous 4 years based on new actives. Interestingly, water-based SC, suspension concentrate formulations, are coming to the fore here, which is suggesting that formulators are finding ways of formulating microorganisms as liquids without the problems mentioned previously. So let's summarize then, how in general would we say that biopesticides are being formulated? Well, in general, we go through the same process, the same thought process as we would go through for synthetic actives. First of all, we need to consider the physical and chemical properties of the active and the target application, and then choose the formulation type accordingly. And some examples here of low water soluble hydrophobic natural extracts which are formulated as emulsifiable concentrates, for instance. Then obviously, as we've said already, living organisms can't actually be dissolved. They wouldn't work if they were dissolved. They can only be dispersed. So they won't be formulated as EC and SL formulations. You won't see those for living organisms. And living systems are often formulated dry. But as we've seen, not always formulated dry, and the key here is to keep the water activity below the level which will allow organisms to grow on storage. So what other approaches are formulators taking? Well, they may be formulating with UV stabilizers to prevent damage to sensitive actives. They may be adding adjuvants to enhance the performance of the active ingredient. And there are many examples in patents and literature of microencapsulation of biopesticides to protect the active and to control release of the active. Some of these have reached the market. Encapsulation technologies can be based on synthetic polymers or on naturally occurring materials. And the nature of the processing is important too. Some processing is more intensive than others due to heat or to shear. So for instance, dry grinding or wet bead milling may be destructive to many bioactives. Here are some examples of formulation derived from our 2016 report. There are even more in the more recent Agro Bioformulations 2020 report as well. For instance, Syngenta published examples of encapsulating emamectin benzoate with a photostabilizer and then formulating it as a spray-dried granule in order to get round the problem of photodegradation of that active. Avamectin has been formulated for controlled release in a novel nanocomposite formulation. Some insect virus biopesticides can be encapsulated in waxes with UV blockers to reduce UV sensitivity. And there is a patent application here on using a superabsorbent polymer to formulate microorganisms in order to bind water, and efficacy benefits were claimed in that patent. So let's summarize that very brief run through of formulation trends that we've discussed today. And although we have added one comment from our 2020 viewpoint, still much holds from our 2017 view. Innovation in formulation is pretty fragmented. The publication rate in nanotechnology is not matched by any visibility of commercial products. The publication rate activity in microencapsulation is pretty high as well, but again, relatively few products are on the market. There is a lot of patent activity in formulation from China. The question is, how significant will that become internationally? The growth of new types of so-called new types, at least of formulations such as SC and WG, at the expense of the older types, EC and WP, seems to have halted, and the growth of old types may be related to an increasing share of generics on the market, or they may be due to the appearance of new solvents and oils for use in EC formulations. Biopesticides, well, that's a big area as we've discussed. Stability challenges are being addressed, such as encapsulation. The nature of the active component dictates the formulation type, as we've said. We think one update, and again this is taken from the 2020 Agro Bioformulations report, we also don't think that that activity, significant activity in patents and publications, is yet matched commercially. So thanks very much for listening to us today. Here are our contact details if you have any questions about this or any other formulation topic. Although we've covered agrochemical formulation today, we are active with formulations for all chemical using industries, including cosmetics, detergents and cleaners, pharmaceuticals, foods, coatings, inks, and many more. And we hope you'll take a look at our other revisited presentations, which you can find on our website, as well as our free webinar recordings. Thank you and goodbye.